my name is Rich Howard, owner of Architectural Builders Supply, and this video is to attempt to replicate a door pull that a client sent to us. I saw the photos and I immediately realized, well, this is going to be 1960s, would be my best guess in terms of a vintage.
If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it.
Okay, so at least a week has elapsed since the last video of just recording it. I feel like I've stormed the beaches of France 70-some years ago. It's been a battle. So here's where I am right now. I have the parts mostly cut, and I have these pieces of plastic on here just for the benefit of vacuum. And there's a couple of more that I still need to complete cutting, but Here's part of the breakdown that we need to get into. So what happened here was, admittedly, I am running the tool unattended, but I'm not comfortable going all the way through the workpiece for a couple of reasons. My tabs, I wasn't at a point where I was confident with my tab not breaking. That part getting loose, obviously breaking the spindle and worse. Also, not wanting to get into the MDF and causing a fire. Interestingly enough, this morning I got a call from the management company at our Enterprise location and said in Unit 46, there had been a small fire last night. Well, Unit 46 is a company that has lots of CNC machines, and that it was smoky at our end of the building. So I was running it 24/7. And I'll tell you this, you really, really, really learn where the weak points are in your system when you stress test it that way. And specifically my water separator with the desiccant media, that was getting clogged, severely reducing my pressure and my flow. And you've got to have flow to run a cold air gun. You really find where the weak points are, and I sure did. So, but the good thing about that is I also learned what it takes to not encounter those weak points. Scheduled maintenance. So in that period I have done 2 rounds of unscheduled maintenance, but I now know what the bottom line is, and I'll just show it to you. This water filter, there are 2 of them that I have that are basically feeding the system. Well, this one on my original regulator line to the 2 original compressors, I did not at all do anything regarding maintenance for possibly a year and a half. Nothing. I wasn't getting any evidence of moisture in the line at all, and I just neglected it. And one day I was not getting hardly any pressure, and I just started taking things apart and discovered the problem. In that desiccant water trap, that desiccant gets clogged was the word that a local air compressor company used yesterday, but clogged is a good word. It's just the material, the desiccant in there, when it's so saturated, it doesn't stick together. It fuses. It fuses. So the air is coming through the top, it's going down through an aluminum tube. At the bottom of that aluminum tube, there's likely a stainless, very fine filter. The air comes down through the aluminum tube, passes through the desiccant, back up and out. Comes down into the tube, out, up, and then to the tool. And you could try to blow on that aluminum tube, nothing's coming out. Disassemble all of it. I'm pouring water into the top of it out of the faucet, and no water's coming out of it, so there's nothing happening. So I learned the problem with that. So what I decided to do was to do partial tool paths. I would go down to just to the top of my tabs on the mounting post. So I'm going down like, 7/8 of an inch. I'm basically going all the way down right to the top of where my tabs will be and leaving the rest. And I said to myself, I didn't say to myself, but I recognized, at least at a marginal subconscious level, that's risky business, because if the part moves at all, that's not really good. Well, so this ran for days, and then I came back the next day after shutting it off. Pumps off. Nothing was touched. No one was here, but the whole workpiece shifted. But that workpiece is, let's say, 20 inch by 20 inch. It shifted, and I could see evidence that it got moved up a little bit. So I was able to kind of measure that and move the workpiece in Vectric down that 15 thousandths. The issue is the part didn't just move in one axis only. It kind of moved like this. So it was okay on the left side of the workpiece with that adjustment, but down over here, on the right side, I still had an artifact. So the whole thing of running it, pausing it, the part shifting, resuming it, major problem. So what my response to that is, well, I'm learning how to better navigate the approach to that. And what I would probably do in the future is, if I'm going to let it run partial, I'm going to offset my part inwards a reasonable amount so I could do the majority of the work. And then, should there be any micro movement in the parts that I'm making, in some parts that I'm making, it's not going to matter very much, because If that part is shipped at 15,000 on what I'm making, it does not matter. That hand wheel project, it does not matter if the pocketing that I'm doing in the center of it is off 15,000, it does not matter. However, with these mounting posts, it does matter. So, last weekend, it's like I had a frat party here. Literally like I had hosted a fraternity party. This shop is in complete disarray. Chris Burns came and we installed the new CNC, the Shopbot Desktop Max ATC. We also installed a HandyBot, which I bought from someone that he knows. And I'll flip the lights on real fast just so you can see it. Now this little HandyBot, I don't know when I'm going to get to actually using it, but it has a X of about 6 and a Y of about 7, so just figure 6 by 6. But let me tell you this, it works. And the way that we've installed it is, this works just like the desktop. There's a card that's in there. I'm just connecting Shopbot to it. It doesn't have much of a Z-axis, but it's got more than I could. It's got 1 inch, so I'm not going to fit anything in there thicker. So it's been exceptionally chaotic here. I mean, the shop is just in complete disarray. So that was a problem with the part shifting. I made the adjustments and it's acceptable. But now we're going to have more post-processing. There's going to be parts that I'm going to want to salvage, those mounting posts, that I'm going to have to file. I have the world's most expensive mobile cart that I'm building, and let me show that to you since we're here talking. I'm going to roll the hand wheel cart project out of the way. This job has not been put away yet because we still need to do our tumbling on these. They turned out really well. They really did. So here's my mobile post-processing cart that is continually being added onto. I get to a point and I say, boy, I could add on more there. I bought an air file, and I'm not ready to really talk about this air file yet, but it needs about 8 CFM. Well, I'll tell you this, what's really neat is I found a compressor that is cordless by Milwaukee. This thing produces just over 8 CFM. There it is. So we're going to get that put on the tool and see if it'll operate the air file. Now, I don't really have a problem with compressed air in the shop, except that I have a major problem with compressed air in the shop. That's a whole different project. I have such an ad hoc system here, going back to the learning the weak points in your system when you run it hard. So what I'm going to do today is Tuesday of any given week, of any given month, of any given year. I'm going to finish the 1 or 2 or 3 that I have left out here. That whole part's going to come off. Then we're going to inspect the entire part. I'm going to show you what had shifted, what had moved. We're going to talk about our next steps. I spoke to the customer yesterday. He called and said, hey, what's the latest? I said that I told him I would have an update for him today, because I will, if that's the point that I'm at. I want to get 2 mounting posts off good, post-processed, filed, tumbled, sanded, whatever, drilled, tapped, show you the final result, and then decide what the next project is. The approach that I've got now is making these mounting posts has taken forever. Part of Chris Burns being here this weekend is because I also had Bryce Pretzel, I forget his last name, highspeedcamera.com. Bryce has come here twice now, and he is set up literally at the end of the tool with his really expensive high-speed cameras. And we're capturing the tool, cutting the material in climb and conventional, different chip loads with different tools. And it has been fascinating to watch all of that work. Well, part of the restriction here is what I learned this weekend with Chris Burns saying you can go faster through aluminum. You can go deeper. My past depth has been 5 thousandths. He says, absolutely not. We need to get you to 30 thousandths. And I'm thinking to myself, wow, I would love that. But I'll believe it when I see it. So sure enough, we start at 20 thousandths, and it's garbage. The cut quality is garbage. Everything's garbage. And we're using ons, roofs, ship load, which we all believe to be fairly reliable, right? Long story short, we burned a couple of router bits, and I'm just scratching my head saying, it's not happening. I'm locked at 5,000s. We got to a point where we were doing 10,000s, and that's great, because that reduces the amount of time in half. But I could tell it was leading to premature tool life. But what I learned is that my feed rate, which was 0.67 inch per second, that I can comfortably increase the RPM to 12,000 from 7,500 and therefore increase my feed rate to whatever it is, 1.2, whatever it is. The bottom line is I've doubled my feed rate safely. Now, why 12,000 RPM? We were running that sucker at 24,000 RPM, which it can, and I SHITU not that I have never burned myself grabbing a tool holder, and while it didn't cause a blister, when I accidentally touched the tip of the tool, that caused a blister. I have noticed that I don't like maxing out the spindle, so I brought it down to 18,000 and then continued working. Feed rate at that point being 2 inch or something, and I didn't like the results. So I said, I'm going down to 12,000 RPM. My feed rate is my feed rate at this point, and we're good. So the process of optimizing has given me a halving of the runtime, almost half, with no degradation to tool life that I can detect or anything else. And the bottom line is, let's just pick it up moving forward.
If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it.
Okay, it is now time to see what we can see in terms of what we've got here. I'll give you a little background of what happened. So I discovered, and just reinforcing this, that truing or surfacing the material was crucial. There's a direct correlation between the predictability of the tool going all the way through the material, 10,000s, leaving a tab that's not breaking loose. Because what I was encountering was a situation where we had pieces around, like in the outside perimeter or corner area, I could set the cut depth and it would work. But when I got away from that area towards the center, yeah, parts were snapping loose. And the reason is because the piece was crowned in the center. That's why I surfaced this or trued this item. Turned out that once I did that, I'll never not do that again, is the bottom line. So what you're seeing on this piece is an instance here, an instance here, an instance here, where the part broke loose. The tab was compromised, it broke loose. On at least one occasion it broke an end mill, which was unfortunate because the tool ran for hours without cutting anything. Yes. The other unfortunate circumstance is that instance where we had a shift in the workpiece. You can see it here. You can see it down inside of there. So the majority of these are probably going to be problematic in terms of needing to potentially do some filing. This whole area up here is probably going to be afflicted with that. There are some in here that are going to be just perfect, and those are going to be the ones that I'll use. So I'm going to put the camera aside. Now I'm going to pull this piece off and we're going to take a look at it. So I'm just going to do that right now while we're rolling. The vacuum pumps are off. They don't need to be on anymore for this job. However, the auto drains are all running, and plus what I learned about the tubing for an auto drain is you do not want to use a soft PVC or a soft tube. I've had to replace 2 tubes already, and I have to replace a third with a harder tube. The amount of pressure coming out of this has burst this tube in at least one position. So I've got to pull that tube off of the tank and get that run outside. So don't make that mistake of using a soft tube for your auto drains. I didn't have a problem with that soft on these 2 compressors, nor on the 2 that are under the stairs, but the 2 at the top and the tank at the top elevated. It may have something to do with distance, actually, which probably makes sense. These two down here that I've not had a problem with, they're going right outside into that roof drain. I'll show you what it looks like on the outside. You don't want that to activate while we're standing here. And then we've got more coming out of here. Someone has walked by and probably pushed our hoses back, which is fine, it's no problem. You don't want to walk past these and get a surprise at 120 psi that there's water being spit at you. So that's okay. Let's go back in and take a look at the piece.
Again, thank you for watching, and if you've enjoyed this video, please click thumbs up, please subscribe, and maybe even send the video to someone that you know. Thank you.